Hi, everyone. My name is Mauricio Montalvo, and I'm so excited to have the chance to be here speaking at the GraphQL Conf. I've been an engineer for 11 years and at Pinterest for 2.5, where I've been mainly focusing on helping the company adoption of GraphQL. There are many things that are scary in life, like giving your first conference talk, bungee jumping, swimming in the open ocean at night, or perhaps one of the worst, production breaking on a Friday night while you are on call. All of these things are scary, but today I'm going to talk about the scariest of them all. How to incrementally adopt GraphQL when you are dealing with a large web page. I'm going to talk about the journey that we have at Pinterest to adopt GraphQL, the problems that we found, and how these problems led us into the ideal solution. How we implemented that, and we are going to see how to migrate the screen. And finally, I'm going to close with the next steps for this project. So let's get started. So for context, the Pinterest app uses React.js, fetches information via REST API, and we use Redux for state management. Pretty standard stuff. And we can look at this screen in terms of page and the React tree of components that we have. In the very root, we fetch data from REST, and then we pass down a pin so other components can display its content. And like most of the REST and Redux apps, we have a problem with overfetching. When you are debugging a page, it's not clear why you have some extra information that perhaps you don't really use to display content. So we wanted to address this problem and improve the developer velocity. So for that, we first tried something called field selections, which is basically passing an extra parameter in the REST request specifying the backend that you want certain properties to be returned in the response. OK, fair enough. That works. So we have a list of properties out of ping here, and we get that in the response. But when you are dealing with larger pages, this starts to get messy. How many properties are you going to have in this list? Like dozens, like 50, 100 properties? Look at this screen. Can you really be sure that every single field here is actually used in the page? It's not really clear, right? So this was not the best option that we have. So, OK, let's use GraphQL. In the end, GraphQL is meant to help you to cut on overfetching. And for context, the backend folks at Pinterest created this API that returns the same endpoints, models, and entities that we have in REST, but in GraphQL. So it just matters about how we switch the data consumption, in this case, from web. So now, let's go and try to find the right migration approach, given the circumstances that we have in the app. So the first thing that we try, OK, let's try to migrate everything in one shot. As a fan of Pinterest and an active user, you might know how large the web app is. We have about 500 million monthly active users, so this is not a trivial task at all. So we have some pages that contains hundreds of React components, and it's not really easy to do. If you want to do everything in one shot, you are going to end up having something like this. A huge PR with tons of code changes that, let's face it, nobody's going to be patient enough to review, and it's most likely going to get rejected. So for an app or of a scale, it's not possible to do everything in one shot. But this takes us to some learnings. We have a new requirement now. We want to incrementally adopt GraphQL to prepare the ground for switching the network requests while we keep on fetching information from REST at the very top. So, OK, why don't we make individual GraphQL requests across the tree? So if we look at this option, we can consider the same diagram, but we are just changing some components so they talk directly to GraphQL, requesting the data they need, and we go bit by bit. So with this, we avoid a huge PR. We can just make a PR for each of these components, but it's also coming with some problems. First, we're going to have more network requests. And I guess everybody can agree that that's not ideal. And most likely, we can be fetching the same information via REST and via GraphQL. So again, this is going to hit us on the loading time. We're going to have more loading states. So now some sub-branches in this React tree are fetching the information directly. So in the meantime, they are going to have to display some sort of spinner or loader, and we don't really have control of whether we display all the content of the page, and this is not great for user experience. If we are migrating a component that is reused across several surfaces, now we are enforcing everybody to use GraphQL. And yeah, we want to get there, but we want to be cautious with that. We are just migrating one screen. We don't want to mess up with other features that are using these components. So the natural step is to duplicate the code of the component, but again, it's not great. We're going to have a version that fetches the information from GraphQL and the other one that receives REST, but this is hard to maintain and it's not an ideal solution. So we can understand that, okay, we need components that can be reused and they can accept either GraphQL and REST information, so we don't have to enforce anybody to use GraphQL yet. So again, with this, we have components reusable. We control what uses GraphQL, and we can roll out as we need. And we don't have any additional network requests. So let's go ahead with that. But before, there is something that we need to consider. We know that the data shapes from REST and GraphQL differ. They have a slightly different shape despite containing the same information. And we can consider that the REST API returns snake case information and the GraphQL API returns camel case. So it's not plug and play in terms of the components consuming the information. So how do we do that? This takes us to the third attempt. Why don't we make components receive scalar properties so they are agnostic of whether the information comes from? So let's imagine this pin header component that we currently have receiving a pin object from REST, and we're going to change that so now it receives only the information that it needs. With this, we can make components reusable. We take the React tree, we migrate bit by bit, and then at the very top, when we reach all of the other nodes ready, we can just swap the call to GraphQL. This might work, but this also comes with some problems. Look at this code. This is not the type of code a great developer like you might be shipping. So whenever you have a very large app with several React components, this starts to get messy. You're going to have to pop drill many properties from the very top to the bottom, and nobody really likes that. So, OK, we need to keep on passing objects. That's just great for encapsulation. And we need to also be able to handle different shapes in this information. So that takes us to the fourth attempt to approach this problem. When do we have a translation layer, which is basically a function that can receive REST information or GraphQL information, and then it's going to transform this into a common type that the component can use, so it's smooth to display the content. And if we want to get to use GraphQL at some point, why not using the GraphQL types for this? Okay, so in here really comes to the rescue. Really has been very useful for us because we can first define fragments for each component, so each component can identify exactly the data they need. And whenever you have a fragment like this one on the left, really is going to generate a type containing exactly the information that the fragment specifies. So that's great because we can use this type as an output of the translation function. And the translation function is going to look something like this. It receives the REST pin, and it's going to be outputting the relay type, making sure that, in this case, publish state gets converted from snake case to camel case. Perfect. So this translation function is going to live inside a new hook that we are going to consume in the components. This hook is going to receive the GraphQL fragment, the REST or GraphQL information, and it's going to be in charge of making sure that the output is going to have the GraphQL shape. So now components are a step forward to the upcoming GraphQL migration, but it's still rendering, displaying information that comes from REST. So perfect. Everybody loves the API, and we are ready to use it across the code base. There is an extra gotcha in here. We will have to write over and over again a very similar translation code. In the end, the rules to convert a pin from REST to GraphQL are the same, regardless of where you are consuming the API. So this is not great for developer experience. You are going to have a lot of duplicated code, and it's just not clean. So a question arises here. Could we automate what these translation functions do so we have a cleaner API and a better developer experience? And the answer is yes, we can do it. How? Well, if we take the same fragment, what Relay is going to do is going to generate this object called reader.ast, which is a quite complex object, but in simple terms, it's a JSON object that contains the information from the selected data in the fragment. And if we can consider this as a small graph, the root in this graph is going to be the pin header fragment, and it's going to contain two scalar properties. That's what I selected in this fragment. So having this, we can automate what these translation functions do. And this takes us to the formal approach for this, something that we call the Relay Migration API. an API that consists of a set of React hooks that behave very similar to the relay functions, but they can receive arbitrary data sources as input, in our case, data from REST. And this can help you to prepare the ground in your React trees to start bit by bit, make components, use GraphQL shaped objects until you migrate everything, and then you can finally swap the root call. So if we recap, we are supporting all this. This is backwards compatibility. We can keep fetching data from REST, but use GraphQL. Components are now reusable. They can accept multiple data sources. We can handle different shapes in favor of the GraphQL types. And we have a clean and easy-to-use API that developers are going to love. So having this context, we can now take a deep dive on how this Relay Migration API works, and we can see an example of how to migrate a surface. So if in Relay you want to use fragments, you most likely want to consume useFragment, which is the hook that you are going to call on each component. What useFragment is going to do is going to take the reader AST for the given fragment, and it's going to try to understand the structure that you are trying to fetch. It's going to get the information from the Relay store, and it's going to recursively build this GraphQL shaped object. So in our case, we're going to create a wrapper for this useFragment hook, which is going to be called useMigrationFragment. That's going to be our own hero. So in here, we are going to encapsulate the logic, and we, of course, are going to make sure that we support the GraphQL only or relay flow, because that's the end state we want to get. So if we look at the code for this useMigrationFragment hook, if the data input is going to be GraphQL, we just call relay, and we support the same flow. The interesting part comes whenever we are sending REST information, or as we call it, legacy data. So for this, we need to call the translation function, so we make sure that we return the GraphQL shaped object. But now we have a stronger, improved, and automatic way to do that. Instead of having to define the legacy translator over and over, now we have something that we call auto legacy translator. And how this works is very similar to Relay. It's going to take the reader AST, it's going to traverse over it, it's going to understand the structure that you want to have in the output, but instead of reading data from Relay, it's going to read the information from an arbitrary data source, the input that you are passing. In our case, information from REST. And it's able to return the GraphQL shaped object. So if we look at some pieces of the code of this auto legacy translator, it's going to traverse through the tree, and whenever it encounters a node that is a scalar field, it's going to take the information from the input, and it's going to insert that into the GraphQL shaped object. But wait, remember that we mentioned that the data shapes from REST and GraphQL are slightly different. So we need to handle that in here as well. So if we look at this code, we're going to improve this. So if we, for example, we could get publish_date as an input, what we're going to do is going to pass this property name into this custom translation function that's going to be in charge of handling either the snake case to camel case or other specific situations that you might have in the naming. And it's going to properly insert that in the output, making sure that we insert this property as published date. So now we can modify the useMigrationFragment to handle one new kind of input. So additionally to supporting the GraphQL flow, we can now support the legacy data. This legacy data is just the same REST information we were sending, but adding some properties so we can identify that properly. And in this case, what we're going to do is we're going to send that to the auto legacy translator, and the same hook is going to return a GraphQL shaped object containing the properties that the fragment specifies. So with this, we can finally start migrating the screen to prepare the ground for the upcoming GraphQL data consumption. So we're going to take an abstraction of the previous tree to make it easier, and we're going to have 3 nodes. The root node is going to be in charge of data fetching, and it's going to pass the REST pin down 2 levels. So we're going to take a bottom-to-top approach to migrate this surface to be prepared for the upcoming GraphQL data fetching. So we take the leaf. OK, in here we implement the consumption of useMigrationFragment. We are past the REST pin inside this legacy data, and now the migration API takes control over this leaf, and we can consider this already using GraphQL shaped objects to display content. We are a step forward in the upcoming GraphQL migration. So now we can move to an upper level, to the middle component. So we already know how to do this. It should be easy. But there is something to take into account in here. I mentioned that every fragment is defining the data that only the component needs. And perhaps the information that the middle component and the leaf component need is pretty different. So how are you going to support that? So if we talk about fragments and fragment spreads in relay land, we can consider that, okay, the pin body component has this fragment, and it knows that it renders two children, the header and the footer. So it wants to spread the fragments for them. And if we could consider this as a graph in GraphQL, we can see that the top query is the root, and then we have some nodes that correspond to the fragments that we have in the page. And all of this information is contained in the reader AST that really generates for a fragment. So in this case, pin body fragment has some scalar fields on the left, some selections, but it also has the information and a node that specifies that we are doing some fragment spread. So we can use this information, the reader AST, so we can process the data accordingly. So whenever the auto legacy translator is going to traverse this tree and it encounters a fragment spread, what we're going to do is going to take the input information and we're going to insert that in the object. So later on in the leaf component, we can use this as a source to perform what is necessary to get to the fragment data. But you might be thinking here, Mauricio, you mentioned that the object only contains the shape that the fragment defines. Where are you going to insert this symbol stuff? Well, we are lagging a little bit here. So it's a secret that please just keep between you and me. This is a key functionality for the API to work, and the users don't really need to understand or to know that this is happening. We are being compliant with the type of the output, but we are just adding some extra information in there. So if we look at the use migration fragment, now we can receive one new kind of input, data that was previously read from our own API. This is going to have the GraphQL shape, but it's going to contain some information that is extra, which is the secret symbol, which has the original input information. We can use that to call out the legacy translator, and then we get, once again, the GraphQL shaped object in return. So we can now support 3 different kinds of input, and this actually makes the leaf component completely reusable. It's completely reusable in surfaces that fully use GraphQL, in surfaces that are in the process of migrating to GraphQL with our API, and in surfaces that just are sending the manually legacy data. So this is key for all this process. So now we have migrated the middle and the leaf, and we approach the root. So in this case, we need to do something slightly different because this is the data fetching layer. So whenever you are using Relay, you might want to call use lazy load query to actually perform the network request to GraphQL. So what we are going to do is we are going to create a new wrapper that is going to encapsulate that logic, and it's going to be supporting fetching data from other sources. So that's going to be called use migration query. So if we look at the code in here, it's going to receive first the GraphQL query, and then the existing logic that we have to fetch the information from REST, we're going to insert that into a function that we pass to this hook. Any network request is going to be passed here, and it's going to receive also this use GraphQL enabled to understand if we want to fetch data from GraphQL or from REST. If we're in GraphQL, we fetch data via relays function. Otherwise, we fetch data with what we had already. So we are ready. Not really. We remember that we have different shapes in the data from REST and GraphQL, and this also needs to be handled at this level. So if we look at an example of a query, we have a query here at the very top, at the root component. So we got the get pin, in which we pass the identifier for this pin, and we have this data object that is wrapping the actual pin content. We don't have all this in REST. In REST, whenever we call the API, it returns the raw pin as result. So we need to handle this, and how? Well, the reader AST that really generates for a query contains all the necessary information, so we can do it. So if we look at this screen, we have the use migration query. It's going to read over the reader AST. It's going to understand all of these extra layers, and it's going to create this wrapper object. Then it can call the REST API and insert the information exactly where it needs to be. And it's going to be compliant, returning the GraphQL shape object that the user expects. So having this, we can finally migrate the root component. And at this very point, We are still requesting data from REST, but we bit by bit made the React tree being able to render GraphQL content, so we are ready to turn on GraphQL finally. This is a very large page, but we achieved so. But wait, before doing that, there is something that we really haven't talked about. This feature is quite crucial in our website. So we cannot risk introducing any regressions in performance or regressions in metrics that we measure in this page. Remember, this is a very large page with a lot of traffic, so we need to be cautious in here. So the natural step is to run this GraphQL variant under an experiment. And this is one of the coolest parts about the Relay Migration API. You have A/B testing out of the box. You can control with this Boolean parameter if you want the whole tree to be fetching data from REST or from GraphQL, and you can easily plug that into the A/B testing framework that you might be using. So that's pretty powerful. So now we can finally start exposing the GraphQL variant to a percentage of traffic, and congrats. You have migrated your surface to GraphQL. Okay, so you run this experiment for a couple of days, weeks. You make sure that all the metrics look healthy and green, and you reach the point in which you are ready for 100% traffic in GraphQL. But before doing so, you start wondering, what happens with the Relay Migration API? I no longer need to support requesting data from this REST API. Should I just keep the code as it is? Oh no, more technical debt. My manager is going to be very happy with this, and yeah, we have more dead code. Well, in the end, the Relay Migration API is meant to be used for transition and experimental phases. You have a very large React tree. You want to prepare the ground for GraphQL, so you do it bit by bit. Once you can turn on GraphQL at the root, you run this experiment, but then you need to clean up because you want to just consume GraphQL. So having this in mind, we also created a script that does static code analysis, so it can understand, given a React tree, what are the components that are shared by other features, meaning like they need to keep supporting both data sources and keep using the migration API, but what are the other components that now can directly use Relay, and that's the list of components that you might need to clean up. So the research task is made for you, so it's easier. What I just described is the most simple use case of the Relay Migration API. We support more advanced cases like arrays, inline fragments, pagination, and refetching, which is very useful to render feeds with a lot of content, and stable references. You might have noticed that we use this Auto legacy translator a lot, and it creates this object with the GraphQL shape out of nowhere. We had to add a cache layer into this, so we make sure that the response for this Relay Migration API is stable, because maybe you want to use this in a use effect or a use callback dependency array. So we want to make sure that this is a very useful API. That's why we have stable references. So far, we have had a very positive reception of the Relay Migration API at Pinterest. More developers are using it to migrate the surfaces bit by bit, incrementally to GraphQL. We have a couple of hundred components already consuming that internally, and a dozen of features that have been fully migrated using this method. Some of them have been 100% shipped to use GraphQL, and some of them are under experimentation. And at this very point, you might wonder, what about Relay Resolvers? Okay, fair enough. Relay Resolvers are another way to achieve something very similar. Request data from external data sources and incrementally migrate to GraphQL and Relay. We have had conversations with the Relay team about this. For our very own cases, there are some stuff in which we needed to create our custom solution, but I'm very optimistic that once these Relay Resolvers are fully rolled out, people in the community are going to have several options to incrementally adopt GraphQL and Relay. So in summary, these are some of the benefits of using the Relay Migration API. First, you can incrementally adopt GraphQL. Your components can consume these GraphQL-shaped objects. And this is very useful when you are dealing with very large pages with tons of components. And you can avoid having to migrate everything in one shot. Your components are reusable, so you keep like the idea of React reusable components. You have A/B testing out of the box. That's pretty cool. You can control how this GraphQL is looking in your website and make sure that everything looks green. And you have consistency and tab safety. So to close my talk, I would just like to talk about what's next for this project. The Pinterest web team has been working on this for about 1 year. We are quite happy with the results. There are still a few things that we want to fine-tune and improve, but the most interesting part about what's next that I'm sure you all are going to be excited to hear about is to open source this project so everybody, thanks. Everybody in the community can benefit from the hard work that we have been doing at Pinterest to make GraphQL incremental adoption easier than ever. Finally, I just want to say thanks to the Pinterest web team who has put a lot of effort into making this happen. This is a team project, and without all of their help, it wouldn't have possible to reach these amazing results. And actually, we have here Robert Balicki from our team who is going to give a talk about another awesome project tomorrow. So please do not miss that. And that's it. Thank you so much. Yeah, that's a very good question. All of this is based on the fact that, as I mentioned, we have a REST API and a GraphQL API that return the same information. If we had different shapes or like completely different shapes or partial information, it wouldn't have been possible. In our very own case, we have a layer on top of the REST API, so that was kind of the faster way the backend team could provide this GraphQL API. But I think this approach is talking just about the front end, but it will depend case by case. But in our case, we have a layer on top of the REST API that returns GraphQL. Okay, yeah, I mean, yeah, of course. And yeah, and that's why also we want to have A/B testing. So the API team provided this, like trying to be sure that we still have not much problem with latency, but that's why we want to have A/B testing. We saw a few problems. We were able to approach them because in the end we are coding on overfetching, right? So it was a bit messy to request so much information in some pages that is not really used. And with the GraphQL and the fragments, we are just sure that what we have is what we need.
Have the entire schema, right?
Yeah, exactly. Yeah, that's a very fair point. In our case, the context is like we had everything ready there. So this is just like a front-end problem of how to switch when you have a large web app. But yeah, you're right. If you don't have the backend in GraphQL, this wouldn't have been possible because there is no schema in GraphQL. So really cannot generate the types. Well, not really in our case, but it gives you the ability to do so. If you find that it's useful to support both at the same time, and it's not like a matter of deciding which one is best, but you just need both for some reason, it's helpful. So you can just decide at the very root with this Boolean parameter under the conditions that your business logic has, like, hey, I want GraphQL, or hey, I want this other data source. Yeah. Yeah, that's a very interesting question. Yeah, all of this is about reading. Right? So it's just about reading the information. We also need to, in one side, keep the client state like available. So whenever we are using GraphQL, we also have a bunch of tools to keep the relay store and the Redux store in sync. So whenever you are coming from a page that is backed by REST Redux and you pass to another page that now it has relay, we have functionality to be able to keep them in sync given the user session. And the same way, the other way around. For mutation, at this very point, we only keep the mutation and the changes to the actual data in REST, in Redux, but that's a step forward that we might want to address once we get there.
Will those utilities also be open source?
Well, I guess it depends on how's the progress for this. But yeah, at least we support the writing part, or an approach to write things to both source, which is basically, if you talk about reading only, it's a common problem that we faced. All right. So thank you so much.